Today, our topic is transistor configurations under common collector configurations. So let us briefly recapitulate what we discussed in the previous class. So previous class we talked about the common emitter configurations. So in common emitter configuration, emitter is common to both input and output side, and we will see the current amplification factor in common emitter configurations beta. So beta is equal to IC by IB. So beta will be 20 to 500 is the range, and we will also see in the input characteristics and output characteristics and also find the input resistance and output resistance, and we will see the different modes of transistor operations like saturation region, cutoff region, active region. So these are the different mode of transistor configurations. Today we will see the other configuration. That one is common collector configuration. We also called as grounded collector configuration. Common collector configuration or grounded collector configuration. Okay. So this is the NPN transistor. So collector is common to ground. Collector is common to ground. So this is represented in a symbol, transistor symbol. So this is the transistor symbol. So in transistor is a 3-terminal semiconductor device which consists of 3 terminals. One is emitter, base, collector. So here you can observe clearly. So this is the collector. So collector is common to ground. Collector is common to ground. Okay. Whenever we are connecting the collector to the ground, so this is input. So this is output. So you can see clearly this collector is common to input and common to output. Okay. So this resistance is called as base resistance. So this is the input voltage. This is the output voltage. This is the emitter resistance. So this is called as common collector configuration. So collector is common to both input and output. Okay. So we will see the practical implementation of common collector configurations. So this is the transistor symbol. Okay, this is the transistor symbol. You can clearly observe. So this is the, so any circuit there is a common ground. Any circuit. Okay, any circuit there is a common to ground, one terminal. Okay, here collector is the common to ground. So this is the emitter terminal. This one is the base terminal. This one is the voltage. Voltage actually here base terminal means this is the base terminal. This is the collector terminal. So there is a voltage exists between these two terminal. One is base and collector. We call it as VBC. Voltage across base collector are also called as voltage across collector base. Both are same. Voltage across collector base or base collector. And also there is a current, base current we will measure by using ammeter, here by using voltmeter input side. So this resistance we call it as, so it is a base terminal means we call it as RB, base resistance. This is the battery or input. Here this is, here also what is the output terminal? So this is one terminal, emitter terminal. This is the collector terminal. So VEC, so voltage across, this is the voltage. Voltage across these two terminals is VEC or VCE, both are same. So voltage across emitter collector junction or voltage across collector emitter junction, both are same. So we represented as VEC. So this emitter current can be measured by using ammeter. So this both terminals, emitter and collector junction voltage can be measured by using voltmeter. You can remember one point, volt in a practical ADE lab, voltmeter is always connected in parallel, ammeter is always connected in series. Okay, so this resistance we call it as RE resistance. RE resistance. This resistance is RB resistance, base resistance and emitter resistance. This is the battery. So this is the practical circuit of common collector configurations. Okay. See, in common collector configuration, so the common collector terminology is derived from the fact that collector, see, collector is common to both input and output side of configuration. So collector terminal, this is the collector terminal. It is common to input. So this is the common. This terminal is common to input and output. That's why we call it as common collector configuration. So conventional current direction is upward or forward to outside. That means it is the NPN transistor. See, this is the NPN transistor. If conventional current direction is forward to base, we call it as PNP transistor. So here you can clearly understand that. So here common, which one is common? Collector terminal is common to both input and output. That's why we name it as common collector configuration or grounded collector configuration. So it is not mentioned here, it is ground. Already it is ground. Any circuit which is already ground, then only it will operate. So here collector terminal is ground, here collector terminal is ground. That's why it is common collector configuration or grounded collector configuration. Okay. See, in common collector configuration, there is a current amplification factor like common base configuration and common emitter configurations. So in common emitter configuration, input current is the base current and output current is the emitter current. See, what is the input current? Input current is the base current. So this is the base terminal. So input current is base current, IB. Input current is base current. Next, what is the output current? It is the emitter current. So IE. Output current is IE. So it is PNP. Similarly, here also same. In NPN transistor, input current is base current, IB, and output current is IE. Okay, output current is IE. That means current amplification factor, change in IE by change in IB. Both cases, change in IE by change in IB. See, change in IE by change in IB. So output current by input current, change in emitter current by change in base current. So the ratio of change in emitter current to change in base current, we call it as current amplification factor gamma. So this circuit provides the same gain as CE configuration. So gain is same to both cases in common emitter and common collector. The only difference is phase shift. There may be a differ. Only gain is equal. Okay. So relationship between gamma and alpha. Generally, this alpha current amplification factor is in common base configuration alpha. This gamma is common collector CC, common collector. So we know that what is gamma? Change in IE by change in IB just now. So this is the change in IE by change in IB. Similarly, alpha. Alpha means base is common. Base is common means common collector means IC by change in IC by change in IE. This is so we know already. We know these things. So what is the basic formula? Emitter current is equal to base current plus collector current. Okay, you can apply both sides. Change in IE is equal to change in IB, change in IB plus change in IC. Okay, change in IB is equal to change in IE minus change in IC. Okay, so IB is equal to change in IE minus change in IC. So gamma is equal to, so this is the formula gamma. So gamma is equal to, we know that change in IE by change in IB. What is change in IB? So replace. So this is the change in IB is equal to change in IE minus change in IC. So this is change in IE minus change in IC. So we will get this gamma. So both numerator and denominator by dividing change in IE. So change in IE by change in IE. Here change in IE by here change in IE. Here change in IC by change in IE. So numerator and denominator divide by change in IE. So we will get change in IE by change in IE is equal to 1. Both are cancelled. Both are cancelled 1. Here also change in IE by change in IE is equal to 1. So change in IC by change in IE. So change in IC by change in IE is equal to alpha. So gamma is equal to 1 by 1 minus alpha. Okay. So expression for collector current. We know that. So collector current is equal to alpha times of IE plus leakage current. So IE is equal to IB plus IC. So substitute instead of IC. So IB, what is IC? So IC is equal to this one. Alpha into IE plus 1 plus IC B naught. So IE is common. We will get IB by 1 minus alpha plus IC B naught by 1 minus alpha. So IE is equal to beta plus 1 into IB plus beta plus 1 into IC B naught. So beta plus 1 is nothing but this is the 1 by 1 minus alpha. Beta plus 1 is equal to 1 by 1 minus alpha. Here also same. Beta plus 1 is equal to 1 minus 1 alpha. That's so 1 by 1 minus 1 alpha is replaced by beta plus 1 into IC B naught. Okay. So beta is equal to alpha by 1 minus alpha. So beta plus 1 is equal to alpha by 1 minus alpha plus 1. We will get 1 by 1 minus alpha. Okay. So beta plus 1 means 1 by 1 minus alpha. Okay. So what are the input characteristics and output characteristic like CB and CC configuration, CE configurations? It is similar to same. So in CC configuration, what is the input CC configuration? So CC configuration means, so I am taking NPN transistor. Okay. So this is the terminal, this is terminal. So this is the common, this is the emitter, this is the base. So input means input side, what is there? VBC. So this junction voltage is VBC. And output side is current is IB. That means input characteristics are VBC versus IB. So VBC versus IB. When VCE is a constant at different voltages. VCE or VEC is constant at different voltages. So this is called input characteristics. So in input characteristics, first we have to fix this voltage, VEC voltage, VEC here. This is the emitter terminal, collector terminal. So in between voltage is VEC voltage. First VEC voltage is put into 2 volts by varying IE current. By varying the IE current, we can fix the VEC voltage at 2 volts. Then we will increase or varying the VBC. We will get rapid change in IB. Okay, we will get rapid change in IB. That means VBC is independent to IB. So without VBC, it is increasing rapidly. Okay, this is called input characteristics of CC. So what do you mean by output characteristics? So output characteristics means same, similar. So this is the transistor, this is the emitter terminal, so this is the collector terminal, this is the base terminal. So output side means right hand side. So right hand side means what is the voltage in between? VEC. So this is the E terminal, this is C terminal, means voltage is VEC. What is the current? Current is IE. Current is IE. So emitter collector means VEC voltage, current is IE. So this is the graph between VEC versus IC. So this is the VEC versus IE. So when IB base current, when IB is at fixed value or constant value. Okay. So first we have to fix IB is equal to 0 by varying VBC voltage. By varying VBC voltage, we can fix the IB is equal to 0 microamperes. Okay. Then we will vary the VEC. Then we will vary the VEC. You can see it is a linearly increases up to this point. Then it is a constant. Similarly, next what to do? Next step, we have to vary the base collector voltage so that we can fix the IB value to 20 microamperes. 20 microamperes. Okay. Then we will varying the VEC voltage and corresponding IE current is noted. Corresponding IE current is noted. So up to this is a linear, then it is a constant. So third step, how to fix the IB value 40 microamperes? By varying the VBC voltage at the input side, we will fix the IB is equal to 40 microamperes. Then output side, by varying the VEC voltage, IE current will be varying. So IE current is linearly changes, then it is constant. Likewise, we can vary based on different IB values. Based on different constant IB values, we can vary VEC by measuring IE. So this region, see, this region, it is this region below left hand side of linear curve. This region we call it as saturation region. Below first IB is equal to 0 microamperes. This region we call it as cutoff region. Cutoff region means the transistor is off state. In this region, transistor is off state. So in this region is saturation. Saturation means transistor is on state, linearly increases the current. But this region we call it as active region. This region we call it as active region. So active region transistor will be working as amplifier. So out of this region, one region is that this region is a attenuator region or inverse active. That is used for some other purpose, suppression of some degrading of signals like that. Okay, this is the three modes of operation in a transistor. Mainly we are using active mode. Active mode means it is working as a amplifier. So input characteristics and output characteristics. So here this region linearly increases, then it is a constant. So this region we call it as saturation region. This region we call it as cutoff region. So this region we call it as active region. Okay. We will find the input and output resistance. What do you mean by input resistance? So resistance formula, what do you for V basic formula? V is equal to IR formula. We want to find the R. So resistance is equal to V by I. So in input characteristics, what is the resistance? What is the voltage? VBC by IB. We call it as input resistance. Similarly, what is the output resistance? Output resistance means VEC divided by IE, voltage by current. We call it as resistance. Okay. See, comparison of these three configuration. One is common base, common emitter, and common collector. So there is a comparison. So input resistance. So the basic principle of transistor is a transfer of input resistance to low resistance to high resistance. Here common base, it is a low. Low means resistance measured in ohms. It about less than 100 ohms. Less than 100 ohms input resistance. So we will process only small signals in common base. That is the meaning. So in common emitter, about 750 ohms. So it is a medium. It is a low, but it is a medium. In common collector, input resistance is very high, about 750 kilo ohms. It is not ohms, it is a kilo ohms. Next, output resistance. So output resistance is very high in common base configuration. So transistor, it transfer the low resistance to high resistance. See, low to high. Next, here also some medium to high. So here 750 and 445 kilo ohms. Here also 750 to here common collector is resistance is decreasing output side. It is about less 50 ohms. Next, voltage gain. Voltage gain is nothing but output voltage by input voltage. We call it as voltage gain. So voltage gain in common base configuration is about 150. Common collector configuration is about 500. Voltage gain. In common collector configuration, voltage gain is less than 1. Next, applications. What are the applications? For high frequency applications, we are using the common base configuration. For audio frequency 20 to 20 kilohertz range, we are using common collector or common emitter configuration. Okay. Next, common collector configuration for impedance matching we are using. See, these all configurations are used for amplifiers. So based on different range of frequencies, we will choose according to that. Okay, for low frequency applications, we use this one. For high frequency impedance matching, we will use this one. For medium range common emitter amplifier, we will use. For audio range, I want to amplify my voice to certain range. I will use my voice is comes under audio range, that is 20 to 20 kilohertz. So at that time we will use common emitter configuration. Next one is current gain. So current gain means output current by input current. So in common base it is less than 1. In common emitter it is high, beta. Here it is alpha. Less than 1 already I told. So it is 0.9 to 0.99. Here beta is equal to 20 to 500. This is appreciable. Okay, this is the current gain. Beta is the 50 to 500. This is also in between 20 to like 100, like that, 20 to 100. So this is called as comparison table of different configurations: input resistance, output resistance, voltage gain, current gain, application, phase shift also. In phase shift CB, there is a 0 degrees phase shift. This is 180 degrees phase shift. This is 0 degrees phase shift. Phase shift wise also there is a comparison. Okay. So BJT specifications, I will explain. We know that BJT means bipolar junction transistor. We will call it as a transistor. It is a semiconductor device. Based on the semiconductor material, we are making to as a transistor. So for example, I am using the silicon material. So it is a silicon BJT. I am using germanium material. I will call it as a germanium BJT. Okay. So this is called VCE sat, means voltage across a collector emitter. So saturation region. Voltage across base emitter saturation region. Voltage across base emitter active region. VBE cut-in region, VBE cut-off. See, four modes just now I told. These are the four modes. One is VBE saturation, active, cut-in and cut-off. Okay. How it will appear? So V saturation means it is a both junctions are forward bias. It is both junctions are forward bias and forward bias. Here active means forward bias and reverse bias. First junction is forward bias, second junction is reverse bias. Cut-in means, what do you mean by cut-in? First cut-off means RB, reverse bias and reverse bias. So cut-in means reverse bias and forward bias. Okay, so you have to remember these values. So VCE saturation for silicon diode is 0.3, VBE 0.7, saturation, VBE active 0.7, VBE cut-in 0.7. Cut-in means after 0.5 volts it will conduct cut-in voltage. After 0.7 volts it will be active. For example, so this is the graph. After 0.5 volts it will conduct, then it will conduct. After 0.7 active means it is a constant active at 0.7 volts. VBE cutoff means 0. Similarly, germanium diode VBE saturation 0.1 volts, VBE sat 0.3, VBE active 0.3 and VBE cut in 0.1 and VBE cutoff minus 0.1. So remember, these values may vary based on temperature. So there is a phenomena we called thermal runaway. Based on temperature, electrons may acquire energy and increases the current. At that time, these parameters may change. So we will consider 0 degrees Kelvin and 3 degrees Kelvin. So room temperature and 300 degrees Kelvin, we will different values are there for this. Okay. So these are the BJT specifications. Okay, in this class, I will summarize what I discussed. So, common collector configuration. So, in common collector configuration, collector is common to both input and output side. We call it as common collector configuration or grounded collector configurations. So, in common collector configuration, current amplification factor we denoted by gamma. So common collector configuration, so output by input, gamma is equal to output by input. What is the output current? Change in output current. Change in output current is equal to what do you call? Change in IE by change in IB. That is called common collector configuration amplification factor. So, and also we've seen that input and output characteristics. So input characteristics is nothing but V's input characteristics is nothing but VCE versus IB when VEC is constant. That is called input characteristics. What do you mean by output characteristics? Output characteristics is nothing but collector and collector terminal, emitter terminal. So voltage is VEC versus IE when IB is constant, different value of IB. We call it as output characteristics. Okay, and also we will see a comparison of these configurations: input resistance, output resistance, voltage gain, current gain, and applications also we will see. And also some specifications of BJT. It is different values: VBE saturations, VBE cutoff, VBE cut-in, VBE sat, VCE sat for germanium diode, similar to silicon diode. Okay. Thank you.